Hello and welcome to GradCast, the official radio show and podcast of the Society of Graduate Students at Western University. I am your host tonight, Gavin Tolometti.
And I'm your co-host, Rhys Paterson.
And we are here with Tabetha Shepphard from the Earth Science Department. Thanks for being here tonight.
Thanks for having me.
So I guess to kickstart this all off, tell us a little bit about what type of research you do with the Earth Science Department.
So my research focuses on hydrothermal alteration, so right after an impact in impact craters. So I take a look at alteration minerals, so when a mineral has changed from one thing into another, because water, slightly heated water at least, has passed through it and changed the chemistry of the rock. And then I focus on these hydrothermal alterations within impact craters, so locations where meteorites have hit the Earth. So that we can see what hydrothermal system activity there has been in the craters.
So what does this hydrothermal activity look like, I guess? Is it active, or is this like past alteration that once existed?
What I look at is past alteration, so it's not still active, but on Earth itself there is active hydrothermal alteration going on, mostly underwater. People would know them as black smokers or hydrothermal vents down at the bottom of the seafloor, usually at things we would call spreading centers. So there is active, but what I'm looking at is basically like a past record of the active hydrothermal system in craters. So it's not hot anymore.
Have you been to any impact craters?
I actually grew up in an impact crater, so I'm from Sudbury. And Sudbury is second largest impact crater, I think, after Vredefort. So I've been in my fair share of craters. Brent Crater as well in Algonquin Park I visited. And I was supposed to visit Meteor Crater this summer, but that got canceled. So we'll see if we can visit that one later on too.
All right. So I believe that you said that your research has changed since the course of COVID. How much has that changed since you first started at Western?
Yeah, it's changed quite a bit, mostly just because geology is different all over the world, and it's very case-by-case basis depending on where you are. You're not going to find the same rocks and same geology in different locations. So when I first started at Western, I was supposed to be studying a crater in France called the Rhys crater, which had a lot of unanswered questions, not a lot of research done on it. There's a research center based for the crater in France, and I was going to be looking at its hydrothermal alteration. So I spent quite a few months taking a look at core sample pictures, and I was meant to go spend at least a week or two in France, choose samples from the core to study. And now I had to change that since we can't go to France right now and the labs were shut down, so they couldn't even send me samples that I would want because they could not go since it had gotten bad in Europe before it got bad here. So I was forced to change to a different crater completely in Canada in northern Quebec called West Clearwater crater, which is a whole different geology, a different time period, different alteration style completely. So I pretty much had to start from square zero, except for my base research on actual impact cratering. So it's a little tough. I'm still trying to get back into the groove and get familiar with these samples now.
I feel that really hard.
I was also pretty adamant on wanting to do my own field work because I find it difficult to look at other people's field notes of where they collected their samples and images, and maybe it's not organized the way I would want and the data's not great. So now that I have to work completely off of someone else's samples and someone else's data, that's also a little bit of a struggle for me.
Is that what the summers mainly consisted for you because of COVID, trying to go through past field notes and try to figure out what information you can gather about the crater?
Yeah, so I started over on my literature review a lot of the beginning of the summer, so trying to read up on West Clearwater and what's different about this crater from the one that I had read almost all of the papers on from France. And then also having to look through one of my supervisor's past students' personal notes and the thin section notes, and taking a look at the how the rocks were named and where they were from. And not a lot of the Excel files that they had were very well labeled, so I had to spend at least a week going through our server and checking every file and seeing what Clearwater 3 was and what data that was, because they weren't really labeled very well. So it's been a struggle for that. But yeah, most of my summer has been spent organizing other people's notes.
I can relate to that. I'm studying a crater that's all the way in Labrador, and I was supposed to go also this summer, but that got canned because of COVID, and I've been trying to go through some field notes and sample IDs, and majority of the information's there, but some of it's missing, and I don't know why it's missing. So it's made it hard to get context. But I guess with that, have you been able to look at any samples that have been brought back from that crater, since you'd mentioned that your supervisor's past student took field notes there, so I'm assuming they may have brought samples back for you to look at?
Yeah, so I do have samples, which is why we chose this crater, because it's from a previous student my supervisor had who ended up not completing their PhD. So I have samples, and we even have a little bit of data. We're currently trying to get the old XRD data that was done for some of the samples from the lab. So hopefully I'll have some data at least already done. Nothing with fluid inclusions was done though, so I do have to make fluid inclusion slides and take a look at the fluid inclusions all myself, but hopefully some of the XRD is done, and then I'll have to take a look at those thin sections under a better microscope than the one I have here in my apartment when I'm eventually brave enough to start going to campus more and more. But at least we have hand samples, we have thin sections made. Everything is pretty much done in that sense, unless there's any hand samples or large rocks that I want made into thin sections that aren't already done. But the majority is there, ready for me to just start on the microscope right away.
So I just want to quickly backtrack a couple steps. I think it was two things you mentioned there. There was XRD and there was fluid inclusions. Do you want to quickly explain to our audience what XRD and fluid inclusions are to us geologists?
Yeah, so XRD is X-ray diffraction. So in my case of how I've seen XRD before that I did in my honors, is we use powder for ours, and you put it into the X-ray diffraction machine, and X-rays are kind of aimed at it, and it's used to look at the actual crystal structure of the minerals. And it can be incredible tool to tell even the smallest amount of a mineral within the sample. And I look at really small, fine-grained clays and alteration minerals that are a little bit hard to identify in a microscope. So you really have to crush it into a powder, or some XRDs you can just put an actual rock slab in it and the X-rays can bounce off of it properly. But I've only really done work with powdered XRD. But it'll tell you, it'll spit you out kind of like a graph that looks weird with peaks and valleys, and based on those peaks and valleys you will tell where the X-rays were absorbed or not absorbed, and then you can identify the crystal structure, and then with the crystal structure you can identify what mineral you have in the powder. And then fluid inclusions are something pretty special that are trapped inside of a crystal. So it's fluid from the hydrothermal system, or whatever fluid was passing through that rock gets trapped inside of like a little bubble inside of your crystal, usually somewhere between the crystal lattice. Some of them can be just in like little pockets, and then it's a preserved piece of fluid from that actual system. So people who look at hydrothermal systems, it's really useful because you can take a look at that fluid and see exactly what the temperature of the fluid system was, the pressure. You can tell its composition. So was it saline? Was it not saline? You can also tell what the gas composition was. If there was lots of CO2, CH4, within the fluid. And that is extremely useful in telling us where that water came from, how hot it was, and what the pressure was, especially after an impact. That might tell us how long after the impact the hydrothermal system was in place, and maybe how long it went for based on the alteration we have, as well as the fluid inclusions. So you take those little bubbles and you crack them open and you identify what's inside of them, or you can also put them on a heating platform and slowly heat the bubble back up until it's no longer a gas bubble and a liquid. It turns into one solid kind of fluid inclusion, and then you can really tell the temperature in which it formed at. So there's a few ways of using them.
So what type of minerals are you looking at? Like, what type of minerals do these fluid inclusions form in under an impact situation?
It depends on the situation, obviously, but you can find fluid inclusions in quite a lot, mostly quartz. So quartz is a really hard mineral, very common, SiO2. Everyone loves quartz in like the crystal world, but us geologists are kind of like, oh, sand, you know, like everything is quartz in this world. So mostly quartz, and West Clearwater is pretty interesting because it does have a lot of quartz bugs, or these basically like empty spaces, we would consider them, which are common in hydrothermal systems, which a lot of the quartz in there could potentially have held fluid inclusions. But you can also find small fluid inclusions scattered in other minerals, as long as they had some kind of a fracture or somewhere for them to be trapped in. At least that I know of. I'm in my master's, it's the first time I'm working with fluid inclusions. So I'm still doing a bunch of reading on them. So if I get anything wrong, I'm sorry.
Oh, that's not a problem. We're all here to learn new things. So when you look at use these fluid inclusions to look at the temperatures of these fluids during, and I guess also after the impact event has occurred, is there anything you can learn about it? Like what type of environment these fluids may have temporarily made for maybe, I don't know, some form of life that might have tried to exist after it occurred?
Yeah, so based on the composition of the fluid, so what is in it, you could likely tell at least where the fluid might have come from, whether it was seawater, underground aquifer, maybe lake water, is it, or what we would typically say meteoric water, kind of like rainwater that's seeped into the ground. Whether it was like magmatic fluids, so maybe it's high in metals and it's carrying around some cool stuff. It can definitely tell you if there was the potential chance for life, if there was the key ingredients to life within those hot fluids. Definitely impact craters are like a cradle for life. They have great environments for it because there's little fractures that protect from UV rays. There's that hot water flowing, and just like underwater, those hydrothermal vents, those are a place where people think life started on Earth. So those, once active, when water was flowing through all of these cracks and really hot and crazy kind of an environment after a meteorite just slammed into the Earth, would likely have the potential to host life. Fluid inclusions being like for sure the thing that says there was life, I don't think would be the only thing we need to tell. That would be a question more for some of Oz's other students who are more biologists. I'm not sure what those key ingredients are that we need for life, but you can also tell if the crater might have had possibility for a mineral deposit or a future mining site that we would have today, like Sudbury or in South Africa. They're big economic geology mineral deposits formed at these impact craters. And looking at the fluids, you can possibly see if they might have been carrying metals. And you can also tell through the rocks if they were leaving behind metals and other things that the hot water would have transported and placed in one spot and managed to form a big deposit. So there's a few things you can look at.
it seems like they're really, really important for the development of the world, and as well from, as you said, like a biological aspect, finding life and all that kind of fun stuff in there.
Indeed.
It almost sounds almost a bit ironic that what we consider to be a devastating force that wiped out the dinosaurs could potentially be the reason that life could have initiated on Earth. So it's very interesting to think that a meteorite impact can give life and then it could easily take it away, even if it wanted to.
Absolutely.
So I guess with that then, since if it is a potential location for early life to have formed, or microbial life, I'm guessing this probably is also being studied on other planets such as Mars, since finding extant or extinct life on the red planet has been a huge drive for a lot of planetary scientists. Do you think that some of the work you're doing can overlap with some of the searches they've been doing on the red planet?
Yeah, absolutely. So one main thing that's important to study hydrothermal systems and alteration here on Earth is just trying to get as much data as possible on what it looks like. Since every impact is different, every impact crater is different, different sized, different timing, whether there was enough heat generated to even form a hydrothermal system or enough water available to circulate, as well as what geology was already there and what are the signs that there was a hydrothermal system based on that rock. So since every location has different pre-existing rocks before the impact, almost everywhere might have different alteration as well. So Mars might have its own very special alteration based on its pre-existing geology and where the impact might have hit. So the more kind of this bank of data we have of what minerals might be a sign that there was hydrothermal activity at that specific crater, the more we can use that to compare to Mars and other planets and take a look at sort of data from there that'll tell us what the mineralogy is, or rover data that we might be getting soon from Perseverance that has an X-ray diffraction machine on it that can tell us what kind of alteration material we have. And if we can safely say that there was hydrothermal activity there, we would know that there was hot water flowing. And hot water flowing is a good sign for life. So signs of hydrothermal systems in craters in general can definitely help trying to see if there's life on other planets.
All right. Side note, do you believe that there's life on Mars? Do you think?
I believe there either is or once was like microbial life. I don't believe there's some aliens walking around hiding from the rover, kind of walking around the back of it, hiding from us, but I believe there's very potentially sort of those amino acids and maybe archaeobacteria or something hidden deep somewhere in a fracture of a crater or something that used to be a lake. But those of us who look at Mars know it's very dried up now, but it is possible it was once this warmer, wetter location. So if there was life, it could have been back then and now it's gone. It didn't have the chance to develop, but I believe either at some point in the past, currently, or in the future, there's potential.
All right.
I'm just picturing aliens hiding behind some of the boulders, laughing, pointing at the rover, going, "Oh, look at this slow, primitive thing trying to learn about our planet. Let's throw some rocks at it and try and toy with the humans on the other side."
They were the ones keeping the drill stuck in the ground. Yeah.
Yeah. They saw the chance. Like, quick, add the glue. But. So I also noticed from the bio you sent us that along with your research, it looks like you have quite a strong background in outreach as well, and especially when it comes to teaching about space to a lot of elementary and high school students. What is it that got you into outreach in particular?
Well, if we're going back really far, when I was young, I started volunteering with Dynamic Earth and Science North in Sudbury when I was in high school to get my hours. And then when I chose to pursue science, I kind of thought, well, I need a side job, and I'm moving to Ottawa. And a friend of mine suggested that I interview for a tour guiding position at Parliament. So I managed to get it, and I became a tour guide. And being this social, very extroverted person I am, I loved it. I just love being able to talk to hundreds of people in a day and see people from all over the world and get to chat. And when I switched into geology, because I had originally started in biomed, that did not work out. When I switched into geology, I kind of created my own tour of Parliament based on the rocks inside Parliament. So the building stones, the different sculptures. People would often on tour ask why the rocks looked the way they did on the wall and why there were these gray streaks through them, which turned out to be trace fossils that told us a lot about the environment that the rocks were facing, which was a shallow marine in Manitoba at the time, where we were actually in a tropical location as Canada when those rocks formed. It was a really cool story to tell on a Parliament tour, and I just became kind of obsessed with sharing really cool science facts with people who will give me the oohs and ahs and actually be entertained by them, and not just people like my other geology friends were like, yeah, we know, I don't care. And then from there, I started working at the Science Museum and the Science and Tech Museum in Ottawa. And it just kind of grew from there. They let me fix up their mineral demo because it wasn't that great to start with. So I helped them with that. And then I'm here at Western, and I chose here because I wanted it to be big on outreach and to get that experience in outreach and communications, because that's kind of where I see my career going. I am too social to be stuck in a lab most of the time. I do see myself going into a more communications-based science life.
You can see those same Parliament stones at the John Labatt Visual Arts Building.
Oh, really?
Yeah.
Limestone?
Yeah. There's the trace fossils, and there's some nice like algal blooms that are on the side of the building. Unfortunately, the really nice fossils are up on the top, so you need like almost like a cherry picker or something to look at them. But you can see all the trace fossils, and you can see the well preserved algal blooms and stuff. It's cool.
It's such a nice stone. It's absolutely amazing.
I think I need to go take a look at this building and find these algae blooms. So along with outreach, I also noticed that something that maybe a lot of the listeners probably won't be able to pick up, that English actually isn't your native language. It's actually French.
Yeah, French is my first language. I did my entire elementary, high school, even my bachelor's degree was done in French. So this is technically the first time I'm doing an entire degree in English. But my mother is completely Anglophone, but my father is a Francophone from Sudbury. So I did have what we would call in French une famille hexagone. So it means you have one of each. So I, at home, was very English since I lived with my mother very young, but at school was completely French. And if you have ever been to a Francophone school, you'll know that they yell at you if they hear you speaking English, because they really want to preserve the language. And they're like, here we speak French. You can speak English when you go home, but when you're here, practice your language. So both languages kind of grew for me, but the only real education I had was in French. So even though my conversational English is great, writing academic type papers and stuff like that in English is a little bit of a struggle, especially math. Math terms are hard and physics terms are hard because none of the words are the same, and I don't know what they're asking me for. When they ask for velocity, I don't know what you want. So that's been a bit difficult, but I am strongly pushing Western space to translate a lot of their outreach programs and science communication efforts into French as well. I know how it feels to be an elementary school and high school student that doesn't get classroom visits and you don't get summer camps, and you don't get video YouTube resources or people tweeting in French about everything. You know, there's some from France or Quebec, but not to the same level. And I just believe that some institutions that create these big programs, it would be really nice if some of them were offered to the Francophone students. I have this heartbreaking story from my one friend from Northern Ontario who they had both the French and English students in the same school. And the school students were invited down south to meet Roberta Bondar, the astronaut. And the French students didn't get to go because it was just for the English students. And that must have been heartbreaking to see that the English students get to go to these cool events, but you don't because it's not offered in your language.
So they didn't, it's all because they just didn't have a translator to go down with them?
I think it's because the program was in English, so they only really invited the English students.
Oh my gosh.
I don't think they even thought of getting a translator.
That's what I said. I would have thought that'd be quite a easy fix. Just like, there's someone here speak English and French. Okay, yes, you're in charge of translating to the French-speaking children.
You'd think so, but is there a French translator that goes with our Western space camps and talks to French students in class? No. And that might be something easy to do as well, but it just didn't get done because most people only speak English and they might not think about those that primarily speak French.
Yeah, I kind of wish my French was a little bit better because when we had an event at Exploring Earth in 2018 at the Science Center in Ottawa, and half the students that were visiting were, since they're Ottawa schools, I know half of them speak French. The problem is we have some things that you're not supposed to climb on, but I didn't know how to say, please do not climb on this, it's fragile in Quebecois, or in Francophone, so I was like, I don't know what to say. Only the English-speaking kids can understand me at the time. So I felt really bad because it wasn't their fault because I just couldn't tell them.
Yeah.
Yeah, my French is really rusty. I did French for probably up till grade 12. And that was just like conversation. But I'm sure if you started talking French to me, I'd be like, yep, yes, slowly. Longtemps, s'il vous plaît.
But so I really wish we had more time to delve more into Anglo-Saxon and Francophones, but it seems that we're just about out of time for our episode. But Tabetha, if anyone wanted to contact you more to learn about your research, to learn about outreach, where could they find you?
So I do have a Twitter and an Instagram, both called Impactful Rocks. So it's a little bit of a pun. So they're rocks full of impact, but they're also impactful.
Okay, we'll make sure to put that in the show notes for everyone. So thank you again, Tabetha. So this has been Gradcast, the official radio show and podcast of the Society of Graduate Students at Western University. I've been your host, Gavin Tolometti, and my co-host was Rhys Paterson. We've been speaking with Tabetha Shepphard from the Earth Science Department at Western, and this episode was produced by Laura Munoz. If you would like to be involved with the show or get in contact with us, email us at gradcastradio@gmail.com. You can follow us on Instagram, Facebook, or Twitter at GradcastRadio. To listen to us, we are on Radio Western 94.9 FM. You can also find all of our episodes on our website at gradcast.ca or on podcast apps such as Podbean, iTunes, and Spotify. Alternatively, select podcasts have been uploaded to YouTube at Gradcast Radio. Thank you for listening and have a great night.